Okay, it's time to get back to the Unisonic 21 here and put an end to the question of what the problem is. I have capacitors to recap this now. After I said I wasn't going to, I found out that Arrow is a much more viable option than I thought, and we'll be taking a little bit of a look at what I got from them. And, well, we're going to see if it was in fact the VFD, because the fading going to this side doesn't feel like a capacitor problem. And once this thing started getting a little brighter, it seems like it got better. And I think I have an explanation of what happened there, but we'll save that for when we get inside. For now, let's take a look at the capacitors I ordered for this. Okay, so I'm going to start off here by saying I spent $1.10 total on capacitors for this thing. And I actually bought enough of them to essentially recap 2 of these, because you should always just buy extras, especially when stuff's that cheap. Now, I paid, again, $1.50 free shipping, okay? So when I placed the order, I got these literally the next day. So Arrow's whole thing is free overnight shipping on orders. And I always thought there's got to be some kind of catch to that. That's too good of a deal. So I'd ordered just capacitors, a really cheap shipment, and got them the next day for $1.10. That's crazy. But it gets even crazier, because these aren't all the capacitors needed to recap this. No, I had maybe not picked the most ideal capacitors to order, and I accidentally had to get some shipped from Norway, from a different distribution center. Now, this was still the same order that cost me $1.10. Matter of fact, if we take a look at the invoice on here, this order was 5 cents with free shipping from Norway. Now that's just crazy, right? You know what's crazier? This still wasn't all of the capacitors. No, there was another box from Norway that cost 7 cents. 2 boxes from Norway. International shipping. These weren't super fast. These obviously didn't get here overnight like these capacitors did. But 5 cents and 7 cents for each box. And obviously, they paid FedEx, the shipping company, something to ship these. So, on this particular order, I have no doubt Arrow lost their shirt on it. So, that was my fear, is that, say something like this happens with Arrow orders, that you'd end up being charged, like $10. Well, obviously, I could decline the ability to charge if that was going to be something like that. But no, this was free. So I paid, again, $1.10. Got 3 separate packages of stuff. These just came in a bubble envelope the next day, like I said. Got 3 separate packages from international destinations with no additional charges. So, yeah, the Arrow free shipping deal is very, very real. So I will be taking full advantage of that in the future, because that is remarkable. Now, also in the future, I'm going to try and order just from the US warehouse, because it did take about a week or so for these to get to me, and that kind of killed the motivation or the momentum for doing this video. That's why it took a little while longer. Matter of fact, I think I got it, late February, and I've been sitting on them for a while. So, yeah, but still, next day shipping, that's going to be revolutionary for making repair videos. No more Fry's Electronics capacitors for me, which, I should order a capacitor for the IBM CGA monitor. That would be... Man, should I just try ordering 1 capacitor on Arrow and see if they'll ship it? Because what are the limits here? I mean, this was $1. I don't know. Let's get this thing opened up and start taking a look at replacing the capacitors. All right, here we are back at the capacitors. And I want to briefly explain something I said about these capacitors last time, in that the 50 volt values on them are unusual, because I'm going to stick by that. They are. Now, there are reasons you would have 50 volt capacitors. Like in this case, we're powering a VFD, which is going to be a relatively high voltage device. So you're going to need to develop a high voltage and need capacitors that are rated for that. But most devices nowadays, the highest voltages, unless you have some unusual power supply or amplification requirements, are going to be 12 volts at maximum. So 50 volt capacitors aren't going to be necessary. You typically get 16 volt capacitors. So I was assuming that Fry's Electronics would not be catering to the now relatively obscure needs of higher voltage capacitors. But it turns out they were, and they were available. Now, I'd also like to mention why the capacitors that were available at Fry's Electronics were $2 each. It's simply because they're individually packaged, likely rebranded capacitors from some weird company, and they're very low volume products. So that's why they are so expensive. You're not supposed to be buying all of your capacitors there for all of your repair projects or for creating something new. It's mostly hobbyist grade, just basic general electronic stuff. It's really not meant to be affordable. But now that we have this open, we can go ahead and take a look at the replacement capacitors that we have. While the Norwegian packaging just gets more and more hilarious, the capacitors were in a box, in bubble wrap, in a box, in an ESD bag, in bubble wrap, and then just loose. They weren't in an ESD bag like these ones are. I've almost always got stuff shipped in ESD bags, even if it doesn't make sense. There's no need to ship capacitors in an ESD bag. But just, wow, that was so expensive for them to ship. That's crazy. They are clearly losing money in the enthusiast market, but they're probably gaining a lot of brand rep for this. So I mean, if it's working for them, that's awesome. I know they have my business from now on, but it's not going to be profitable. And the other box was loose capacitors in bubble wrap in this giant ESD bag without the cardboard this time. No tape. This is funny. All right, going over everything we've got here, we have the 10 microfarad capacitor, the 0.47 microfarad capacitors, the 33 microfarad capacitor, and the 1 microfarad capacitor. So, like I said, I nearly ordered enough to do 2 of these. I would have just needed 1 more of these, but in general, I just like to have enough to say I totally screw up and rip out one of these legs, soldering it poorly. So, you know, just to have some spare parts on hand, because you never know. Especially with SMD stuff. You never know when you're going to pinch something with your tweezers and it's going to shoot out across the room. All right, I'm going to go ahead and start getting the capacitors removed, and I get to use this new solder fume extractor on video for the first time, so I'm curious how horrible that's going to make the sound. It's just going to make it really bad. This is a Hacko knockoff I found at Goodwill. And what's funny is the day before I found this, I actually found a real Hacko, but it was a 240 volt model. So I don't know what that was doing here, but whatever. This one's 110 and works. So, yeah, I'll just be using that. One thing I'm going to be keeping in mind this time is that this circuit board sucks and the traces lift up really easily. So I had this one slightly lift up on that pad last time, so I ran a bodge wire over there. I'm going to make sure I'm a little bit more careful this time just to ensure that that doesn't happen again. But if it does, I'll be running more wire. Yeah, that loose pad right there, and you can see the circuit flexing. Eek, that's the trace flexing there, actually. That's not good. I forgot about this side too. Yeah, this circuit board just sucks. All right, now that we have the old capacitors out, I want to practically demonstrate something to you that I don't think I have done yet. So I have the old 33 microfarad capacitor on here. We can see we're getting a good reading, and we have an ESR of 9 ohms. Now, that is pretty high, but it's also not, I mean, it's not good for sure, but it's not horrific for, say, an older capacitor like this, an older cheap capacitor like this. But if we grab one of the new 33 microfarad capacitors and throw it in here, and we can just slide that directly in, we're going to see we have 1/10 the ESR. Now, for reference, an ideal capacitor would have an ESR of 0. So the lower the better. This is a much healthier modern capacitor, so that's why the ESR is lower. Now, the change in capacitance between this one and that one, there's a couple of reasons. The electrolytic capacitors are meant to be measured at a slower frequency. If I wrap this around to 100 hertz, we're going to get closer to 33. And they have a 20% tolerance. So if this is about 27, the ideal rating's 33, that's about on the edge of 20%. That doesn't mean you're guaranteed to get one that's 20% off. It's just within that range. Although you are likely to get one between 10 and 20% off because they would spec the ones that are within 10% as a different bin. So you're not likely to get a magically better capacitor. You're just going to get one that's, it's good enough. But that is clearly a much better capacitor to have in there, and I'm sure if I measure any of these other ones, I will see the same thing. Matter of fact, let's go ahead and use the really big one and throw that one in there too to see how that goes. Okay, and here we have the 10 microfarad capacitor, and we can see that it's not quite as far gone as the 33 microfarad capacitors, and if I put the new replacement in there, we'll see that it's actually a lot closer. I'm wondering if maybe the 33 microfarad capacitors I bought are just really low ESR. They weren't special on the ordering form, wherever it ended up. So yeah, I don't see anything strange about those. And there you can see the 20% rating. But yeah, that's still going to be fine, and those are going to be fine. Just kind of generically with ESR, lower is better. So, and again, the frequency being different isn't going to matter too much. All right, I'm going to start off with a wider shot here because I'm going to go ahead and prep the board because it still has solder in the vias there. Well, around the pads, they don't go through, they're not plated. So yeah, this is really going to suck. But if I'm going to put the capacitors in, I need to get them cleaned off. I wonder how many pads I'm going to lose here because this thing is not doing well. So yeah, this is going to suck. Alright, I think I might have actually got that without damaging it any further. So, let's try sticking in the capacitors and see how it goes. Oh, that didn't sound good on the backside for that one. See, did it actually go through the pad? It did. It sounded like it pushed past it. Ah, that one pushed past the pad. That's a mess. You can see it hanging up there. Ugh. That sucks. I don't think that pad will survive if I try and solder braid clean that. I did forget that one. I'm just gonna solder the pad to the side of the leg. Whatever. It'll be fine. Worst case, I bodge wire it. You know what? That's very unsettling. I'm gonna bodge wire it. It's just not worth leaving it like that. It'll break. I know it. Okay, that should be a lot more secure down the road. And that's it. It's recapped. All right, I've got some batteries in there, so let's see how this goes. Yeah, that first character is still really dark. I think those are brighter, but yeah, it's clearly not the capacitors because that should have gone away if it was. Pretty sure that is brighter, but yeah, that's clearly a bad VFD, which yeah, I did kind of have some back-of-the-mind suspicions that it was that, and people in the comments of the last video were telling me that it was most likely that, so yeah, I'm definitely going to go with that. VFD's bad. It has lost the V of VFD, the vacuum, and there really isn't a way of repairing that. The damage has been done. The vacuum is gone, now that there is moisture inside, and the elements are going to be just going bad in there. So, there's not a lot that can be done about this. Now, I did link in one of the comments, at least, that there were some new old stock displays on eBay, but upon further inspection, they are not the same model. They have a MEMSET indicator on the other side, and not just straight up 7-segment numeric displays like this one has. So they're not a drop-in replacement, they just have a very similar model number, which the model number on here is probably just a variant format so that they could have different models. Now, I could try and watch out for one of these to see one come up on eBay, but frankly, it's not worth it. I'm going to go with what I said originally, that if I'm going to get one of these fully functional, I'm going to start with one new in the box. And some people criticize that comment because a new in box example would be just as likely to be bad as this one, and I agree. The difference is, though, that this one is in very poor cosmetic condition. I mean, I'd shown the back of the unit in the last video. I'd shown that it's missing whatever labeling goes here. This shouldn't even be off. It broke. So this one's not a good example of one of these calculators. If I'm going to fully restore one of these, replace the VFD, well, I already recapped this one, and just take the time to make it as good as it can be, why would I start with one that's just of lesser quality? I should get the best one I possibly can and start with that. So I'm going to leave this calculator as it is right now. There's really nothing further to be done. I could possibly try and modify the circuit on here to increase the voltage to this, but you can see how inconsistent it is on here. If that becomes bright enough to see, these are going to be bright enough to blow the elements. So that's just not going to work. Matter of fact, you can see it's even inconsistent within the elements. These are a little bit darker. So there's just nothing to be done for this, unfortunately. Well, that's it. I put it back together and the plastic display cover's back on. I'd say there are two main takeaways from this video. One is that when I see one of these Unisonic calculators at a thrift store, I should probably just keep walking because they're kind of more trouble than they're worth. Oh, that one's pretending it's okay. Trust me, it's, yeah, it's not. And the other thing is that Arrow is awesome. I'm definitely going to be buying a lot more parts from Arrow in the future. So, yeah, that was fun to find out. But yeah, for now, that's pretty much it. This calculator, that's it. That's the end of the road. It's not getting any more work done. It's not going anywhere. It works. I mean, you know, if I clear it, 5 plus 2, or 0, there we go, equals 7, if you could see that. So, I mean, it's functional. It just has problems. So, yeah, that's it for now, though. If you want to support the channel, I am on Patreon, but for now, I hope you guys enjoyed this look at finishing up the Unisonic 21, and I'll see you next time.